Hey everyone, this video is going to be talking about the intersecting chords theorem. In any circle, if you draw two chords, chords are segments that connect one point of the circle to the other. It can be a diameter, but it doesn't have to be. What's going to happen is you can measure their distances, okay? But more importantly, in this problem, I can actually make like triangles on them. So let's pretend for a moment that I were to connect this point to this point. Make a triangle, and this point to this point, and make another triangle. Now, it turns out that this angle up here is the same measure as this angle. And I want you to think about why that is, okay? Those inscribed angles open up toward this arc, and it's the same arc. So it's going to be half that arc. It doesn't really matter what the angle is. Just know they're going to be both the same regardless of where they're drawn because they open up to the same 2 points on the circle. Similarly, the angles down here open up to this arc across here. So they're going to be the same. And finally, the angles in the middle of the triangle, of course, will be the same because, well, they're considered vertical angles and they're across from each other. So what we have ourselves is two similar triangles. And what you need to know about similar triangles is the proportions of their sides are equal. So I know that in this triangle on the left side, C divided by A is going to be equal to the proportion of the sides on the right side, B divided by D, because they are similar triangles. Now, if you do a little cross multiplication here, get rid of those fractions, you're going to get A times B is equal to C times D. So in any circle, when I have intersecting chords, the product of the two parts of the chords that are on the same chord is equal to the other product of the two parts of the chord that intersect at that same point. Okay, so works for any circle because of those similar triangles. Therefore, we can solve a few problems to solve for segment lengths. Let's do example 3 below. Important thing is to label everything you're given. So if I know AE is 10 inches, I'm going to put 10 right there. I'm going to color code this if possible. And EC is going to be 15 inches. That's going to be a different color. So I'll do like a dark red maroon there. That's going to be 15. That'll be here. And then finally, DE is going to be 12 inches. Now that's going to be along this one as well. So I'm going to keep that the same color. We're going to put 12. And notice the ones that are in like a dark brown red, they're following the same chord. And what we want to find is EB. We'll call that one green. EB is what we're looking for here. We'll call that X. Notice that the 10 and the X are in the same chord. The 15 and the 12 are in the same chord. So what we can do is we can say 10 times X, 10X, is equal to 15 times 12. That simple product allows us to solve for the length of X. So 15 times 12 divided by 10 will get you your answer. All right, you're going to get what? 18. So X is going to be 18. Our units are going to be, we're talking about a length here. In this case, it says 18 inches. So we'll put inches for our units here. Try number 4, see if you can label that accordingly and solve for the asked measurement. On pause it if you want to check your work. All right, so number 4, we are going to label everything we have. FM is going to be 10, so we'll put a 10 along there. MG is along the same chord. I'll leave that red. That's going to be 6. And we are given PM is 4. We'll use blue. So PM is going to be 4. We are asked to find PQ. Now, PQ is the whole chord. So we actually have to do a little preliminary solving before we can get it. What we need to solve for is MQ because that's the part of the chord that's going to multiply with the 4. So we're going to call MQ X. And what we're going to do is we're going to set up our equation 4 times x. And we're going to set that equal to the 10 times 6 that we have. All right, 4 times x is, well, 4x, 10 times 6 is 60. So 4x is equal to 60. 60 divided by 4 will get you x. Now, that's 15, but that's not your answer. When you know x is 15, you have to then go and say, well, if I know that's 15, and I want to know this whole length, I'm going to add the 4 and the 15 together. So what does that give you? Well, it's going to give you 19 in this case. So PQ is that whole chord. That's going to be 19 units. It didn't give me centimeters or inches, so I'm just going to say 19, but 19 units in whatever dimension that is. All right, I'm going to scroll down here, so get your work written down if you don't have it. All right, example 5 is a tough one. I would recommend watching me do the first one and then trying the other one because there's 2 parts to this one. So here we go. In circle shown, AP is 3, EQ is 4, PQ is 5. I'm going to make that one green again so you can see how it's on that same chord here. QB is 7, so another green one. And PD is 18. So that's going to be a different color since it doesn't follow on there. So I'll make that blue. All right, so we have 2 parts here. First one is, what is the length of CP? CP is along the same length of the 18. So I'm going to make that blue. And we'll call that X. So, and the problem here, there's some extra information. You don't need everything to get CP. We just need to know what we're multiplying on the green segment. So if you look at your cutoff, P is the point where those 2 chords intersect. So this length right here is going to have to be combined and multiplied with the 3 on this side. So what I'm going to do, I have the X and the 18. Those are going to get multiplied together. So we'll say 18X. But that's going to equal 3 times the sum of 5 plus 7. So those 2 are going to add to 12. Because that cutoff point's P, so I'm really looking at this whole length here in totality. So I'm going to say 3 times 12. Let me put 5 plus 7 here so you can see that sum there. And that's going to give you 18X equals 3 times 12. 3 times 12 is 36. So 18X is equal to 36. Divide by 18, you'll get X. And X is going to equal 2, which means CP will equal 2. Let me put a little blue 2 on there. So that little length is going to be 2. And now I can try for DQ. So what I want you to do is, now that you see me work that one out, see if you can solve for DQ using the segments that you see. DQ is going to be this red one over here. Let's call that Y. And I'm going to erase my markings here and start fresh. Going back to just my original information here, I am going to put Y for that. You can see now that that cutoff point's not P anymore. It's going to be the letter Q. So I'm going to multiply the 4 and the Y, the 4 and the DQ. But I'm not going to set that equal to 3 times 12. What I want to do is I want to combine these 2. So that's going to be 3 plus 5, which is going to be 8. So it's really going to be 3 plus 5 times 7, or 8 times 7. So 4Y is going to equal 7 times 3 plus 5, which is 8. So 4Y equals 7 times, let me fix that here, 3 plus 5, not 3 plus 8. So 7 times 8, not 7 times 3 plus 5. That's going to give you 7 times 8 is 56. So, and then divide that by 4, you'll get your answer. And 56 divided by 4, well, that's going to be 14. So y is going to equal 14, which means dq will equal 14. So there you have it. And just to double check to make sure that that works, if you multiply the 4 and the 14, you get 56. If you multiply the 7 and the 3 plus 5, you can always go back and make sure that verify that that product along this chord with that Q cutoff point is equal to the product along that. All right, there's one more example down at the bottom of this page. I'm going to take this off here and take a look at it. Pause the video if you think you can try it, and unpause it after you've made an attempt. All right, here's the setup. This is going to require a little bit more algebra, so be very careful how you set that up. We're going to say 9 times x, so 9x. And then I have these two x minus 1 times 2x. I'll put the 2x on the outside. So that's my setup. 9x equals 2x, x minus 1. We are asked to find the length of dA. dA, we'll have to plug the numbers back in, but you notice that dA is this whole length here. So I'm going to worry about that last. Let's focus on solving this. We're going to need to distribute that 2x. So first, I'm going to have 9x is equal to 2x times x is 2x squared, and 2x times -1 is minus 2x. Next, we want to get this to quadratic, so we're going to have to get that equal to 0. So I'm going to have to subtract the 9x from both sides. If you're not the best at solving quadratics, I would just recommend using a graph to find where it meets these meet each other. I'm going to solve this by hand, so I have to pull up my graph. So 0 equals 2x squared minus 11x. Now in this problem, we're kind of lucky we don't have a third, constant number, so we can just factor out the x here, and that's going to give you 2x minus 11. Now, when you're solving the equation, theoretically, you'd actually have two answers. You would say x equals 0, and you'd say 2x minus 11 is equal to 0. Now, it's impossible for x to be 0, because then you would have no length there. So that's not a real number here. But what we can do is we can solve this 2x minus 11, and that's going to give you 2x equals 11, and 11 divided by 2 is 5.5. So now that I have x, I can go back and plug numbers in. So if x is 5.5, I can go back and say, well, that's going to be 5.5 minus 1. Well, that's going to be 4.5. And over here, if I plug in 5.5 to this x, I'm going to get 2 times 5.5. That's going to be 11. So let's look at that 11 and 4.5. That's going to be your combined lengths. And so dA is going to be those two added together. $15.5. So that's your algebra for you. Again, thanks for watching, guys. Hopefully you're able to do your assignment. Let me know if you have any questions. Have a good one.